Hello everybody, I am Zach Peterson, back here again on the DENPAFLUX channel, ready to talk to you today about EMC reviews in your PCB design. Now, what is an EMC review? Well, every PCB needs to comply with radio emissions regulations and industry standards on electromagnetic compatibility. And an EMC review is intended to identify all of these issues that might exist in an electronic design. EMC reviews can be pretty extensive, and one way to get through it quickly and accurately is to keep a checklist of items to look at in an EMC review. That's what we're going to talk about in this video today. Let's go ahead and get started. Now, I'm sure a lot of people out there know me from all of the design reviews that I do on YouTube and that I post on social media. And of course, I try to bring up and identify EMC risks in those design reviews. But an EMC review is a bit more in-depth than just looking at the schematics and the PCB layout. An EMC review requires identifying potential EMC risks in the system architecture and in the functional requirements, and those can live inside of the schematics or the PCB layout. It also requires identifying potential violations of EMC standards, whether those are industry standards or radio emissions regulations. This means the items that we keep in our EMC design review checklist should focus on two areas of the product specification: the functional and non-functional requirements, and the product architecture. First, let's just consider, what is the product architecture? Well, the architecture for an electronic product defines how all of the different functional blocks that create the end user experience connect together, communicate with each other, and receive power from a power source. They can also define how a device interfaces with the outside world, such as through sensors or connectors and cables, or interfacing with other devices. Typically for PCBs, we like to break a product up into its functional blocks and show what those connections are between the different functional blocks. And those functional blocks and the connections can include different levels of detail depending on what the product needs to do. Some of the information that's included in that architecture should be intended to help a reviewer who's going to look at the design or evaluate it for EMC risks. Let's take a look at an example design that was submitted to me on LinkedIn from Ahmed Zarara. Here we can see we have a block diagram for a battery-powered device that includes several functional blocks. We have an ESP32, we have some wireless interfaces, and we have a display, as well as some battery and power management. While this architecture nicely shows the connections between all of our functional blocks, it hides a lot of potential risks that we can't see just by looking at a block diagram. But it does give us some items that we should include in an EMC review checklist to ensure that we're going to comply with radio emission standards and industry standards that are relevant to this product. For example, with this buck boost converter, is this an isolated DC-DC converter? Is this stepping down to a single voltage and powering all the devices with the same voltage? Or are there LDOs that are used to step down to lower voltages at different logic levels? This is just one example of some of the information that's very critical to system functionality, and it could impact the device's ability to comply with EMC requirements. Let's take a look at another architecture example from Mohammed Ahmed Ibrahim. This was also submitted to me on LinkedIn. Here you can see we have much more detail about the power architecture. We can see all of the voltages very clearly marked in this architecture, and we can even see interfaces named on some of these connections between these connectors and the STM32 block in this block diagram. We can also see some pin names selected for these GPIOs and for this ADC going over to the stepper driver block, and we have some additional information for these auxiliary devices, the switches, and the ultrasonic sensor and the servo. Just from looking at this architecture, there are some items that we can identify that we should include in an EMC checklist. For example, do we need any filtering on, for example, these CAN lines? Or do we need any filtering on the USART or I2C lines? These are important questions because they can impact common mode emissions if these signals ever route onto a cable through these connectors. We would also want to make sure that we review this power block. For example, if you're looking at this architecture and you see that this buck converter has a 20 amp output, you might assume that it's galvanically isolated. In that case, we would want to make sure that we apply best practices for galvanic isolation and check that in our EMC review, and we want to keep that in our checklist. For example, are the primary and secondary side nets properly named? Is there a Y-type capacitor connecting the primary and secondary side if it's needed? What are the voltage and leakage current specs on that capacitor? Those are just a couple of items that we would want to keep in our checklist if we were reviewing this functional block in this design. Power, grounding, and interconnects are three of the most common areas where EMC problems can arise, either due to susceptibility to external EMI or to emissions through common mode noise. These areas need to be addressed through aspects like filtering, usage of chokes, making sure we have the proper grounding strategy, and of course linking grounds back together in the correct way for our application. The next high-level area that we would need to look at in an EMC review looks at our functional and non-functional requirements for the product. Functional and non-functional requirements are compiled into a product specification, and if you saw our earlier video about the 10 common EMC challenges, you will know how important a product specification is. This document often contains testing requirements and EMC standards compliance requirements that are applicable to your product. Let's take a look at an example product specification document and see some other things that we should include in our EMC design review checklist. Here on screen, I have an example product specification, and you can see that it comprises everything from a simple product overview to mechanical requirements, all the way to electrical design requirements, and finally, electromagnetic compatibility requirements. From an EMC design review perspective, we can see that we're in the right section in this document because it lists the specific EMC standards that will apply to our product. You can see here that we have test references that are listed, we have some specific standards that are listed in the left column, and we have a description of those standards here in the central column. Now, these IEC standards are industry standards, but as we scroll down through this document, we actually see an FCC standard that is going to apply to our product because this product is destined for the US market. This is FCC Part 15, and we can see here that we have a Class A and Class B specification that may apply to this product. Class A or Class B specification needs to be specified if your design needs to function to FCC Part 15 radio emissions regulations. Now, FCC Part 15 isn't the only radio emissions regulation, but it is a common one for use in residential environments and for products marketed for use in commercial or industrial environments. If we scroll back up to the functional requirements section, you can see some items that we would want to examine in an EMC design review. For example, we have this input voltage section. Here, the input voltage is specified at 24 volts DC plus or minus 20%. We also have listed as a functional requirement reverse polarity protection and surge protection using a TVS diode. Here in the DC-DC conversion section, you can see that we have some component placement requirements which will impact EMC and the ability to comply with radio emissions regulations. In particular, we have placement of bulk electrolytic capacitors and high-frequency ceramic decoupling capacitors at the input and output sides of the DC-DC converter. We have another item here under the signal interfaces section, which is for the RS-485 interface. You can see here that we require an isolated transceiver, and this will impact our grounding strategy as well as our ability to implement ESD or surge protection on this interface. As you develop your product specification document, it's always a good idea to list the corresponding EMC requirement, if it exists, for each item in that product specification. These items could include layout and routing, PCB stack-up design, layout and placement of specific circuits, as well as power and grounding strategy. Once you've completed your EMC design review, what's the best way to communicate the results to your project stakeholders? Well, take a look at the example report that we have on screen. This report was generated with DENPAFLUX, and it illustrates some important points that need to be addressed in the next revision of a design. Here in this example report, we see several items that should be addressed by the design team, such as missing current ratings on a power regulator. Here we have conflicting EMC requirements. Here we also have insufficient or outdated standards definitions. As we scroll down to the architecture section, we can see some additional issues related to the system architecture, such as no grounding strategy, undefined power distribution, and lack of circuit protection on key interfaces. If you want to learn more about what you should keep in your EMC design review checklist, or if you want to get a copy of the sample report, head on over to DENPAFLUX.com or check out the links in the description. You'll be able to access the sample report, and you can read more about EMC design reviews and the critical items that belong in the design review checklist. Thanks for watching, everybody, and if you haven't subscribed to the channel, make sure to hit that subscribe button and let us know in the comments what you keep in your EMC design review checklist. We'll see you next time.